Hello friends, welcome back. Welcome to Pebbles SSC Geometry. We are learning chapter number 1, Similarity, and now we are going to study exercise 1.5. Of course, as you know that I am not going to solve each and every example, but we are going to discuss all the examples here. So let us start exercise 1.5. The first problem is very simple problem. The sides of triangles are given below. Determine which of them are right angle triangles. Now all the triplets are given and you have to decide whether these are the sides of right angle triangle or not. You already know that hypotenuse square is equal to addition of squares of other two sides. If this expression or this equation is true, then that triangle is a right angle triangle by the converse of Pythagoras theorem. So they give something like this, 8, 15, 17 or 9, 40, 41. What you have to do? You have to square all the sides and then you have to check whether the addition of any two square is equal to the third square or not. If it is there, then by the converse of Pythagoras theorem, that triangle is right angle triangle. So in example 1 there are 6 sub questions. The 6 triplets are given and you have to check whether these triangles are right angle triangle or not. Let us go ahead to the second example. In the figure is given. Second example we are solving. The figure is given. In this figure, A, B, C and D, A, B, C and D, this is right angle and this is right angle. In the figure, angle BAD is 90 degrees, that is BAD is 90 degrees. Segment AC is perpendicular to hypotenuse BD. AC is perpendicular to hypotenuse BD. Show that AB square is equal to BC into BD. I think we have solved this problem when we were discussing this topic. But let us write it down. AB square is BC into BD. AB square is BC into BD. This is what we have to prove. The second we have to prove that AD square is equal to BD into CD. AD square is equal to BD into CD. And third is AC square is equal to BC into CD. AC square is equal to BC into CD. We have already seen the same problem when we were discussing some solved examples when we are discussing this topic. Okay, this is extremely simple. We know that these two small triangles and this bigger triangle, all three are similar to each other, and by using that similarity properties, what we have to do, we have to prove this, because when you prove BC into BD, when you prove this triangle is similar to this, then you can easily take the ratios of the sides and then we can easily prove that. Let us only prove first and rest 2 you can do by yourself. So the first statement you have to write that by the similarity in right angle triangles, triangle ABC is similar to triangle DBA. DBA, ABC, this smaller triangle, is similar to DAC. These two small and one bigger parent triangle are similar to each other. Now for proving the first thing, we have to take these two, first two. So I can write that AB upon DB is equal to BC upon BA. So AB will go that side. So AB square is equal to BC into DB. Very simple proof. BD is nothing but DB and BC is there. Similarly, you have to take the other two pairs each of the two pairs, and you have to prove these two. So now it is very simple. Please pause your video here and you have to solve these two. For second example, what you are going to do, you have to take similarity in these two. And for the third one, this is for second one, and for the third one, you have to take similarity in these two. Correct? Very simple. In the second, AD square is there, so I will take AD first, that is dA upon DC is equal to dB upon dA, and so dA will come on one side and the rest of the things will go on the right hand side. So please pause your video here and solve these two examples. Do it now, please. Example number 3. This is somewhat like a word problem. A ladder 10 meters long reaches a window 8 meters above the ground. So first of all, we'll draw the figure. The figure is important here. We will say this is the ground level. Window is somewhere here. The window 8 meters above the ground. Let us say this is the point A, which is 8 meters, which is a window, and this is the ladder. I'll complete this line. The ladder is 10 meters long, and this is right angle. A ladder 10, hello, check 1 2 3 4. A ladder 10 meters long reaches a window 8 meters above the ground. Find a distance of foot of the ladder from the base of the wall. Very, very simple. You have to find this distance. Okay. Now, this is the very simple figure. Okay. This is a word problem of Pythagoras theorem, or maybe a right angle triangle. In the trigonometry, when there is applications of trigonometry, you have to draw somewhat complicated figures. So don't neglect this figure, draw the figure properly, okay? Because this is, you are going to use such kind of figures you are going to use in trigonometric, application of trigonometry, okay? So now it is very simple. The ladder is BC and you have to find the BC. So by applying the Pythagoras theorem, you can easily find a length of BC. Please pause your video here and find the value of BC, that is the distance of ladder, foot of the ladder to the wall. Do it now, please. The answer is 6. Now they have said that it is 10 meters and 8 meters, so your answer should also be in meters. The unit is very important. Again and again I am telling you. You will say, the students who are watching my all the videos will definitely laugh at me that sir is telling every time the unit. I am telling you this because I have checked so many papers where the units were missing and I have cut the marks for that. Okay, that is why I am reminding again and again that don't forget the unit, not in mathematics, not in physics. Okay, so answer is 6. Let us go to problem number 4. Problem number 4 we have already solved while discussing this topic. The 4 is, prove that the sum of squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. Now I told you this, that first you should know what is rhombus. Okay, rhombus is a quadrilateral whose all the sides are equal in length, but the angles, internal angles, are not right angles. It has two diagonals and these two diagonals are mutually perpendicular to each other and they are the perpendicular bisectors of each other. Okay, that means both the diagonals, if I draw the rhombus, these two diagonals are perpendicular bisector of each other. This is what the rhombus is. Okay. We have to prove that the square of the sides of a rhombus, that means AB square plus BC square plus CD square plus DA square is equal to sum of the squares of its diagonals, AC square plus DB square. Now how will you solve this problem? Now before solving this, first understand that this BP and DP, these both the segments are half of DB, and AP and PC, these both are half of AC. Okay, we are going to make use of this. So we'll just consider this triangle, triangle APB. Okay, so we will apply the Pythagoras theorem for the triangle APB. So AB square is equal to AP square plus PB square. But we know that AP is equal to half of AC. So I will say it is half of AC square plus half of DB square, that is AC square by 4 plus DB square by 4 is equal to AB square. Now we will take this for this side. So we have 4AB square. Don't ask me why this 4 will go to that side. Okay, it's just a LCM. 4 is common. Is equal to AC square plus DB square. So we have 4AB square, but all the sides of the rhombus are equal in length. So instead of AB square plus AB square plus AB square plus AB square, 4 times AB squares, we can write AB square plus BC square plus DC square plus DA square, and hence it is proved. So please pause your video and write down the example or solve this example properly. Please do it now. Example number 5. The perpendicular AD on the base BC of triangle ABC intersects BC such that BD is equal to 3CD. This BD is equal to 3CD. Actually in my figure BD is looking small and CD is looking bigger, but this figure is not to the scale. Okay, you can draw this figure properly. Just extend this and take this point somewhere this side, so that BD will look like bigger than CD. Okay, but this is a hypothetical figure, not to the scale, so this statement is given. What we have to prove? 2AB square is equal to 2AC square plus BC square. Now how you will solve this? Just think of it. Now first of all, this is given, BD is equal to 3CD. Okay, but what is BC? BC is nothing but BD plus 3CD. Okay, so first of all I will write that BC is equal to BD plus CD, which is equal to 3CD plus CD, that is 4CD. This is what BC. BC is equal to 4CD. We got it. Now we will take these two triangles. Okay, because what we want, AB square we want, which is a hypotenuse, and AC square is also hypotenuse. So in this case we will use these two triangles. So in the first triangle, I'll just name these two triangles 1 and 2. In the first triangle, AB square is equal to BD square plus AD square. This is the first equation we get. And the second equation we get, AC square is equal to DC square plus AD square. This is the second equation we get. We will just subtract these two equations from each other, because see, this AB square we have, and if you take this AC square this side, it will be AB square minus AC square, and that is why we are going to subtract it. Okay, because this question may arise in your mind, why not addition, why only subtraction? So just have a look here. AB square minus AC square, when this AC will go to that side, it will be AB square minus AC square. So we have to subtract both. And after subtracting 1 minus 2, what we will get? We will get AB square minus AC square is equal to, AD will get cancelled and we will have BD square minus DC square. Now, do you remember this looks like x square minus y square? So it is equal to x plus y, x minus y. So I will have BD plus DC into BD minus DC. But what is BD plus DC? BD plus DC is nothing but BC. And what is BD here? 4CD, that is 4DC. So we have BD plus DC is equal to BC because from the figure given. What is BD? BD is already given 3DC or 3CD. So I will just substitute this value of BD, which is 3CD minus CD. So we have twice BC into CD. You write CD or DC, it's one and the same. Okay. So now we have got this equation. Now how to go ahead? Now from the what is to be proved, AB we have, AC we have, okay. BC we want, but here BC and CD both are there. We have to eliminate that CD. How will you eliminate the CD? From here. We have found out BC is equal to 4 CD. So CD is equal to BC upon 4. So here I will get 2 into BC upon 4. These two will get cancelled. So we have BC square by 2. Correct? Now just transfer that or the cross multiplication. This 2 is the denominator here. It will go as a numerator and it will be 2AB square minus 2AC square is equal to BC square. So we will have 2AB square minus 2AC square is equal to BC square, and when this 2AC square will go to that side, right hand side, it will become positive, and ultimately we have proved 2AB square is equal to 2AC square plus BC square. So example is little bit complicated. Why? Because students don't understand what to do and why. Okay, so let me explain you once again. We have been given that BD is equal to 3CD and we have to prove that. This is to be proved that. Okay, so now I will just examine this. I have AB square and AC square where AB square and AC square both are the hypotenuse. So I have to make use of these two triangles. Correct? I know that BD and DC. So BC is equal to BD plus CD. And so we have got BC is equal to 4CD. Now as I have to take these two hypotenuse square, I have written the expression. Now AB square and AC square, I have to subtract. Why? Because if at all I have to subtract, then only it will go to right hand side and become positive AC square. So I am subtracted here and I got this equation. Now for the right hand side, left hand side we are okay because this AC square will ultimately go to right hand side. So this part is okay. We don't have to worry about that. Right hand side what we have to do? BD square and DC square minus. So we will split x square minus y square is equal to x plus y, x minus y. So we have got these two brackets. Now BD plus DC from the figure you know it is BC. Now look what happens. We have AB square, AC square, AB square, AC square, and we have BC square, BC square. But here CD is also there, and we have to eliminate the CD. Also BD also we don't want. So what we will do? This BD I will substitute as a 3CD, which is given. So now BD is eliminated. Now we have only CD. Now we have to eliminate CD also. So how will you eliminate CD? From here, BC is equal to 4CD. So CD is equal to BC upon 4. Have you understood how to do this or how to approach such kind of problems? So please pause your video and without looking on the board or on your video, please solve this by your own. Please do it now. Let us solve example number 6. The figure is given. Now this example was for 5 marks in March 2014 exam. Important sum. In triangle ABC, angle C is 90 degrees. Let BC equal to A. BC equal to A. CA equal to B. CA equal to B. And AB is equal to C. Small c. And let P be the length of perpendicular from C to AB. So this is P. Okay, this is given. We have to prove that CP is equal to AB. First we have to prove that CP is equal to AB, and second we have to prove that 1 upon P square is equal to 1 upon A square plus 1 upon B square. Now how will you solve? Let us solve the first part. Now in this you can see that A, B, C sides are given, and this is the perpendicular to the base. Now in a triangle, when you get the product of the side, when you get, simple, when you find the area of triangle, at that time you get the product, half base into height, correct? So we are going to use the area property of triangle for solving the first part. So what is the area of triangle ABC? Very simple. This is 90 degrees, this is 90 degrees. So the area of triangle ABC can be the base into height. That is, area of triangle ABC can be written as half C into P, or if you take, this is also right angle, if you take A as height, what it will be? Half B into A, and so these two will get cancelled and you will have CP is equal to BA. BA or AB, whatever it is. So the first part was very simple, but the only catch was you should able to understand what to do, and I will just explain why to do. You have to see that this is the product of the sides, and when we get the product of the sides in case of triangle, obviously area of triangle. So I have just said that area of triangle by 2 ways, and if you remember I told you that the area of triangle is base into height, correct? But now don't write that this is base or this is height, because in this case this also can be height and this is base. Now this also base and this also can be height. So instead of calling it a base and height, directly you call them as a side names. Okay. So now how will you solve the second part of it? Just think over it. Now we are going to use this property, whatever we have got here. We want a P on this side, left hand side we want P. Here also we can use, this is the third equation, suppose this is the equation 1 and 2 if you write or equate. From this equation what I will get? P is equal to AB upon C, right? But what I want? Square. So I will write, squaring both the sides, I will have P square is equal to A square B square upon C square. Now I can do invert endo. I can write 1 upon P square is equal to C square upon A square B square. But what is C square? What is C square? C is a hypotenuse. By Pythagoras theorem, C square is equal to A square plus B square. So this is equal to A square plus B square upon A square B square. Now simply you can write 1 upon P square is equal to A square upon A square B square plus B square upon A square B square. And so from here A square will get cancelled, from here B square will get cancelled, and you will have 1 upon P square is equal to 1 upon A square plus 1 upon B square root. Okay. Now how I approached the second part of it. I wanted p square, but only p square. How will I come to know? Because this total AB is C. I don't have these two segment lengths. So p square, I already got the p from here, AB upon C. So I made use of this. Once I got p, I found out p square. Then by invertendo, I found 1 upon p square. And here we have got c square is nothing but, by the Pythagoras theorem, is a square plus b square. And hence, by solving that arithmetically, we get the final answer. So please pause your video and solve this example in your own words by properly giving the reasons and etc. everything. Okay, please do it now. Let us solve example number 7. Prove that 3 times the square of any side of an equilateral triangle. First draw equilateral triangle. We'll draw the equilateral triangle. Let it be A, B, C. Is equal to 4 times the square of an altitude. We'll draw an altitude. Let it be D. This is altitude, right angle. Now let's see what we have to prove. We have to prove 3 times the square of any side. So 3AB square is equal to 4 times the square of an altitude. So 4 times square of altitude AD square. Now, how we will solve this? First of all, whenever it is a AB square or AB square is there, that means somewhere we have to use the Pythagoras theorem. Okay, but AD is there, so AB square and AD square are there, but we want only those two. So first of all, let us examine the figure. This is the equilateral triangle. So now in these two triangles, these both are the hypotenuse, are equal, equilateral triangle, and this is the common side, and hence triangle ABD and ADC are congruent triangle by side hypotenuse theorem. Side hypotenuse theorem you already learned in 9th standard. Okay, so by side hypotenuse theorem, congruency of triangles, these two triangles are congruent, and hence BD is equal to DC. Correct? Now since I want square, I can use Pythagoras theorem in this triangle. So here I can say that AB square is equal to AD square plus BD square. Now I have AB square, I have AD square, these two are there, but BD square is also there, which I don't want. BD, I want to eliminate the BD. Can you tell me what is BD is equal to? BD is half of BC. Correct? But BC is also equal to AB. All three sides are equal. So I can say BD is equal to half of AB. So let us write AB square is equal to AD square plus half of AB square. And hence I can write AB square is equal to AD square plus AB square upon 4. Now just multiply both the sides by 4. So I have 4AB square is equal to 4AD square plus AB square. Take this AB square to left hand side. 4AB square minus AB square is equal to 3AB square minus 4AD square. Proved. Now again, just remember what approach I told you. First of all, I examined the figure. Okay, I immediately came to know that these two triangles, somewhere I have to use the Pythagoras theorem because AB square is there. So in Pythagoras theorem, if I use AB square, then AB square is equal to AD square plus BD square. AD square is there, but BD square I don't want. Okay, so BD is equal to half of BC. For that you have to first prove the congruency of these two triangles, and which is also equal to half of AB. So now I have equation which has got the two things we want, AB and AD. And so I have solved this and it is proved. So please pause your video and solve this problem now. Let us solve example number 8, the last example of 1.5. Triangle is given ABC. In this triangle, AB is equal to AC. So AB is equal to AC. D is any point on side BC. D is any point on side BC. Prove that AB square minus AD square. AB square minus AD square is equal to BD into CD. BD into CD. Now how we will solve this? First of all, as soon as you see the AB square, you must understand that you have to use the Pythagoras theorem at some time in this problem. But to become AB or AD as a hypotenuse, what you require? Right angle triangle. So let us construct or let us draw the right angle triangle. So I will draw this E, which is right angle. Okay. Let this be a right angle or the altitude from A on BC. Correct? Now, can you see that just like a previous problem, this ABE and AEC, these two triangles, side hypotenuse theorem, sides are hypotenuse are congruent given and this side is common. So these two triangles are congruent to each other. So BE is equal to EC. Now I have to use AB square and AD square. This AB square and AD square both are the right angle triangles. Correct? So I will first use ABE. So what is AB square? AB square is equal to AE square plus BE square. And what is AD square? AD square is equal to again AE square minus DE square. Correct? Now we want AB square minus AD square, so we will subtract this. So what we will get? AB square minus AD square is equal to, here these two will go, sorry, here it should be plus. Okay, so these two will go and we will have BE square minus DE square. And you know that left hand side we want as it is, but this we want BD and CD, we don't want E involved in this case. So now here we'll use the property x plus y, x square minus y square is equal to x plus y into x minus y. So BE plus DE and BE minus DE. BE plus DE and BE minus DE. What we want? BD. So BE minus DE. This BE minus DE is BD, what we get. So let us write it down there. This is nothing but BD. Now what about BE plus DE? We don't want, see BD we got. Now we want CD. We want CD. What is BE plus DE? BE is nothing but EC because both the triangles are congruent. So you have now EC plus DE, which is nothing but CD. Again I am telling you, this BE is nothing but EC because these two sides are the congruent triangles. So we have EC plus DE, which is nothing but CD. So it is proved AB square minus AD square is equal to CD into BD. Understood this? Here you can write one more step. I have taken it directly, or you can write that instead of this, from one more step you can write is equal to CE plus ED. This step you can write in between. If you are smart enough to directly conclude it, do it. Otherwise, just do like this. Okay. But if you have to show this BE is equal to EC, then you have to first prove that these two triangles are congruent, and hence BE is equal to EC. Okay. This is what I call as the studying the figure, examining the figure. So please pause your video here, or this was the last example of 1.5. So I am finishing my video here, and you solve this example after this video before going to next topic. So thank you very much. We'll meet in next topic. Have a nice day.